Hello, everyone, and welcome to IoT Show Deep Dive. Today, our topic is CICD, to deploy IoT Edge modules with confidence. I like that word at the end. We threw in the word confidence, and that's normally not things you always use when developing. But we're here today with, I have a couple different speakers, and I'm really excited because all of you are my favorite people at Microsoft, so I'm super happy that, that you're here. And if this is your first time ever coming to a deep dive, what it is I bring my colleagues from the Azure IoT team, from the different teams across Microsoft that's building the products. I'm on the Azure IoT team, and I've worked with a lot of customers and partners and building out these IoT solutions. And throughout the IoT solutions, one of the comments I always hear is, we really want more resources to deep dive into, spend more time hearing from engineering tips and tricks to deploy different solutions. And so this one was actually a top topic that people wanted to hear about. So I'm excited that you're here. So Shin, did you want to give a little bit of information on what you're working on?
Sure, yeah. My name is Xin. Actually, I'm a program manager working for Azure IoT Developer Experience. So I closely with IoT developers, to really learn their IoT development journey and try to turn their pain points into our developer tools, build a feature on top of our Visual Studio, Visual Code, Azure DevOps, Jenkins, so that we want to make sure developers who are doing IoT Edge or other IoT products can really perform the best practice and really turn their business insights to real applications.
Great. I know we've been working with each other for a couple years, so anytime the support that we've had over the years is getting better and better and better, especially when it comes to DevOps with IoT solutions. Yeah. So I've been really excited with all the improvements that we've been adding in new features. For this deep dive, if you have any questions, I'm on chat. I'm your host. So what I'll be doing, I'll give an overview of IoT Edge to begin with, but really we're assuming a lot of things. We're assuming you already know Edge, and that you're interested in how you actually use CICD to deploy modules. And so if you're looking for a huge overview of IoT Edge, we have different videos you can view, but I still think it's really valuable for you to stay on so you can see the process. But I'll be on there if you have a question. I'll be here to ask those questions to our guest speakers. So we have Shin, Kat, and Hava, who are going to be going through a couple different things today. So we're actually, let me switch to our next screen. So our agenda today is that we're going to go over our support for Azure IoT Edge development tools. Next, we're going to actually have two technical demos. So Kat's going to come in and talk about team development with GitHub and Azure Pipelines, and Hava is going to be showing what happens when you have a team, multiple teams working on different modules, and what are some best practices for that. And then Shin's going to come back and show how to use Jenkins to deploy IoT Edge modules. That's actually a request I get a lot because we know Jenkins is super popular. So we do want to cover that. And then at the end, I'll go over some resources to help you get started and also share the GitHub repo that everything you see today, you can go and deploy yourself as well. All right, so I'm going to go ahead and I'm just going to give an overview of Azure IoT Edge. And for one thing I would like to say with IoT Edge is it's great when you want to bring intelligence to edge devices. So think of gateway devices, can even be smaller devices, but it needs to be able to run Docker. But the whole idea of Edge is for you to be able to deploy Azure services that can run on Edge, or deploy your own modules that is a set of code or services that you want to run on an Edge device. It's perfect for situations where you need extended offline, or let's say you need code to execute really fast. Like you have a machine learning module on the edge, and it needs to trigger something on the edge instead of sending all of your data to the cloud and having machine learning on the cloud side.
Right.
You're actually able to quickly do an action, like let's say a machine goes down, and you can have your edge device quickly have some sort of action. So it helps with latency. It also helps making sure you don't have to send all of your data to the cloud, or processing your data on edge side before you send it to the cloud side. So there's a lot of benefits of running IoT Edge. So I'm just going to quickly go over this. So you have an IoT Edge device. In this scenario that we're going to go through, we're actually going to have two sensors. We're going to have a temperature sensor, and then we have a group of humidity sensors. This Edge device is connected to Azure IoT Hub. We're going to create a couple different modules. These modules are really containers. If you've worked with Docker before, it's actually IoT Edge runtime is built off of Moby. So it's very similar. So it's the same concept of containers. So we have one container that has a temperature filter, does all of the calculations for the temperature sensor. And then we have a second module, or you can call it container, that actually has humidity filter in it. So for this example, we'll have two containers. We'll also have the Azure Container Registry that's on the cloud side, because one of the benefits I like to say with Azure Container Registry is that it's nice to have your containers on the cloud side, because what happens if you want to use your cloud in many different types of solutions, it's easier to not have to have all your containers right on the edge device, where then you have to pull from your edge device the containers, and that's not helpful to anyone. And so that's a true value of the Azure Container Registry. You'll probably see throughout this deep dive, I'll call it ACR, but we're going to next deploy those containers to the Azure Container Registry. And then we're going to create a development manifest. That manifest, it tells us on that edge device which modules to install, how to configure them, and it's fully managed service built on Azure IoT Hub. So this deploy manifest, we're going to not only have it on the cloud side, we're going to deploy it on our edge device, which this will actually tell us which containers to install. And you can see from this example, we're actually going to be using our temperature and humidity containers and deploying it on the edge, the right version. So that is a quick overview. I think that's the fastest I've ever talked about IoT Edge. Normally I like to talk about it for a minimum of 4 hours. So I'm gonna go ahead and switch over to the next slide and let Shin talk about our tooling to help support IoT Edge.
Cool. So as a Microsoft, we have like Visual Studio, Visual Code, which is like the world best IDE or editor, which is quite famous across developer world. So we really want to make sure you have your own choice based on your preference. Choose the best developer tools you are familiar with. So if you are a C# developer or C++ developer, you might be very familiar with Visual Studio, like Visual Studio 2019. We already have a IoT Edge extension for that. Basically, you install the extension, open Visual Studio, you can create a new project, quickly create a new solution with C# or C module project, or you can even integrate a module from the Azure IoT Edge module marketplace. The marketplace is a place that people share their modules, or you can also make money from the module published to that place. There will be a UI in Visual Studio for you to browse all the IoT hubs, edge devices, module running status. We also integrated like Windows container debugging support for Visual Studio. I mean, for Visual Studio, it's like if you are totally run everything, develop everything in Windows, you should go Visual Studio. Visual Studio Code is a editor, is a lightweight editor, and it's cross-platform. It's quite famous, and we support 5 different languages. Whatever the world you came from, you can run C#, Node.js, C++, Java, and even Python stuff in Visual Studio Code. So in Visual Studio Code, we also have a tree view integrated in the left panel, which later you can see in the real demo for you to manage all the IoT resources from the cloud. You can absolutely run Visual Studio Code with our IoT Edge tools on Mac, on Windows, or on Linux. But there is another case, like what if you want to choose your own IDE, like Eclipse, or you are a Java developer? Perhaps another scenario is like you want to run everything pure command line. So we also offer you a very cool CLI. The name is IoT Edge Dev. So it's a Python tool you can install from pip, and you can create 5 different types of custom module from just one command. You can build and push your modules to Azure Container Registry or other your private registry. You can also see the container logs from this CLI. So basically, we want to enable you develop IoT Edge modules for on any platform.
And I'm going to sound like a broken record for folks who've been to the past deep dives. I'm a huge visual VS Code fan. So I love the fact that I'm running it on my Mac and everything. And I also love the Azure tools or our extensions. It's just really nice. Especially you have a link to IoT Edge. But if you use the Azure IoT Tools, it's an extension pack and it downloads all of the goodies.
Everything,
all of the goodies. So I'm a big fan of that. But I think I say that in almost every single deep dive. So
okay.
But let's jump into what is the benefits of CICD, and for folks who are joining us who are in the DevOps world, they might already know the benefits, but how's the benefits for when using IoT Edge?
So we just talked about IoT Edge is based on container, and we talk about the developer tools for you to create new project, debug, and run your application on your local machine. So thinking about if you have finished your POC, you are trying to formulate a team doing a real IoT Edge application. What your daily work will be? Perhaps you in Visual Studio with code, you keep debugging, keep deploying to IoT Edge and SSH to that device, see the logs. There are lots of overhead. The round trip, is really time consuming. So without CI/CD tools, you might waste a lot of time in your daily job. But now we will later introduce all the CI/CD tools offering. The CI/CD tools is a methodology that streamlines software through collaborations and automations, and this is the critical component for your DevOps, DevOps philosophy in your team. So you might have different teams, and the teams may have different choice over their developer tools. Like one team using Visual Studio, another using VS Code. So how to make sure they work together. And also, you probably already have some code running on your cloud for your entire IoT solution. How to make better integration tests, deploy all the bits with confidence. So that's all the thing we want to all the benefits we want to give you by offering the CI/CD tools in IoT Edge. We saw this tool is based on container. You can have the similar approach. If you are familiar with the DevOps practice in container world, you can bring the exact same kind of a practice to IoT Edge world.
That's what I like, the fact that we are using containers with IoT Edge. So people who are familiar with that, I know there's still plenty of folks who are building IoT solutions and using the IoT Edge runtime, and it's actually their first time ever working with containers. So we try to make that process not painful for them as well. So it's definitely benefit, especially when you're handling all of those containers.
Mm-hmm. So as I mentioned, we are trying to give you all the choices to set up your CICD pipelines for your IoT Edge modules or IoT Edge applications. If you already have something running with Azure Pipelines, if you are already a Microsoft customer, you probably already have some CI/CD running in your Azure pipeline. You want to have everything as an end-to-end solution. You want to put IoT Edge in the middle of your device and the cloud. You can try our Azure IoT Edge in-house task in Azure Pipeline. And also, perhaps you're a Java developer. You also want to choose some open source platform like Jenkins. We also have a plugin on Jenkins platform. Nowadays, people are, there are a lot of CI/CD systems. What if you want to use the Travis CI, Circle CI? Also, you can use the IoT Edge CI dev tool. We have a documentation for that, how to integrate with these custom CI/CD systems.
That's nice. And were you getting a lot of requests for Jenkins support?
Yeah, of course. Recently, Microsoft doing lots of things about Java stuff, and we found like lots of IoT developers, they are doing Java stuff on the cloud side. They want to bring their cloud workload to IoT Edge, and they already have Jenkins deployed in their company. It's an on-prem Jenkins server. So how they, integrate IoT Edge CI/CD into the end-to-end kind of continuous delivery pipeline. Jenkins plugin is their choice.
That's perfect. They don't have to switch what they're used to. They can just go ahead and add capabilities for IoT Edge without switching.
Exactly.
You can tell we're not on the marketing team
Okay,
because people would
cool.
push us to say Azure DevOps, but we really want to make sure that if you are already working with certain tools or programs or anything like that, that you could still use our services.
Yeah. So this page actually shows what's the artifacts, what's the deliverables in each stage in your CI/CD, and this actually helps you to think about how to design your IoT Edge CI/CD pipeline. So usually when you have your code in Visual Studio, Visual Studio Code, you need to do Docker build and get your image pushed to your container registry. You have different version of your container image. You have to carefully, manage those versions, making sure you get the latest version have been get all the test paths and later pushed to container registry.
Yeah.
Another artifact of IoT Edge application is the IoT Edge deploy manifest. Like you just mentioned, the deploy manifest actually contains described what kind of module needs to be deployed and running on IoT Edge, and what's the different configurations for different types of your IoT Edge device. For example, you probably have different threshold for different types of IoT Edge device talking to the real sensors. You might have different configurations for that. How you do the configuration management, that's a critical problem in your CI/CD pipeline. So once you have all the configuration, all the deployment manifest and the image version successfully managed in your pipeline, you might need to think about how to mapping those things together to your actual IoT Edge device. That could be a set of IoT Edge device. You are doing the deployment at scale. They might have different versions, and you might want to rolling out the versions one by one, or you want to make sure you have everything get tested before you really push the images to the remote IoT Edge device. So I guess we will later show how to do this everything in real demo.
And you can see that this can start getting complicated pretty fast, because when you have different modules which has different versions, that you really do need a process to help you take that image management, configuration management, and then release management. So every part of those is super important, and there's so many different versions of modules you can be going through. So thank you so much, Shen. We're gonna see you back in a couple demos in the future to talk about Jenkins. But right now we're gonna go ahead and bring Kat out to go ahead and start on the IoT Edge, CICD, and Azure DevOps. So she's gonna be coming in to give that overview. And while we're waiting for Kat to come in, it's a really small studio. So while she's coming in, just giving you a little overview, Kat's really going to be going over Team Kat. We are actually going to be showcasing two different teams. And with those different teams, I won't jump into it right now, but I want to make sure Kat has the opportunity to introduce herself. And, yeah. So Kat, which team are you on, and what's your day job?
My day job is software engineer. Hi, I'm Kat No. I'm a software engineer at Microsoft on the commercial software engineering team. And we really work with customers to help unblock them solving tough technical problems. And we take a lot of that feedback back to engineering and try to help improve our products.
Yeah, we used to be on the same team.
Yeah.
So anytime there was DevOps stuff, I'm like, hey, Kat, join in this partner engagement. So she's definitely a big reason why I wanted to have this and have her come in, because her experience and also really helped drive what we're doing in CICD right now. A lot of the, all of the experience working with our partners and customers, all that feedback you drove back in and made these really big changes. So,
yeah, definitely.
Yeah.
And so the demo we're about to go over today is a pattern based off of several customers that we've worked with over the last year, particularly in the manufacturing, oil and gas, transportation industry. So what we're about to demo is actually real code and processes that companies actually go through. So I'm gonna go right ahead and step into the demo. So we're replicating what you would see in a development team at a company. So a lot of times we'll have dev teams that are working on two different solutions, and they'll have their own process and preferences on how they want to do it. So I'm going to be one team, and then my colleague Haddad is going to be the second team. And so I'm Team Kat, because I'm Kat. And my team really loves Visual Studio. So we're going to be creating our IoT Edge module, which is a humidity filter module in Visual Studio. And then Haddad will be demoing what her team prefers. And so our code here this is our development environment, and we do all of our coding in Visual Studio. We host our code in GitHub, so our artifacts are here. And then our GitHub is linked to our Azure DevOps repo. And so in our Azure DevOps pipeline, if we click into the details here, this is for the CI process of our humidity filter module. And it's running on a Microsoft hosted agent, which is Ubuntu 16.04. And there's a few different options here that you could use, or you can self-host if any of these don't suit your needs. And then we are linked to our GitHub repo here, so the one that I just showed. And then there's also multiple options of what you could source your pipeline with. So you could use Azure Repos Git or Bitbucket or anything of your choosing.
That's really nice. I really like that feature, just because if we told everyone they just need to use GitHub when most of their stuff is on Bitbucket, it's just nice to be able to pull. And then especially when it comes to IoT Edge development, there's so many different modules and so many different types of teams, and you might be also working with different partners too who are developing these modules, and they might, have all of their versioning on Bitbucket or something else.
Yeah, that's
Yeah.
a good point. A lot of our customers do use third-party modules too, and those will be sourced elsewhere. So it's good to have the options of where to choose where your code comes from. So stepping into our pipeline a little bit further, we are configured using a service connection, which links our Azure subscription to everything. So you could do it right into your Azure subscription, or you can do a service connection, either or. And so first we're running our .NET tests based off of some of the tests that we have in our GitHub repo. So this is just pointing to that tests folder. And once that completes successfully, we're going to build our module. So this is using the Azure IoT Edge built-in in-house DevOps task. So this is a really nice feature that our dev team has created.
And it just makes it easier to work with IoT Edge runtime and deploy everything you need?
Yes, exactly. So it makes it way easier to integrate your IoT Edge solution into an Azure DevOps pipeline. So you don't have to build this task yourself. You can use something that's already in-house. So what this task is doing is it's building my module image based off of my deployment template that I've identified here. And once that's successful, I want to push that to an Azure Container Registry. And as I mentioned earlier, the subscription you can reference here, or you can use a service connection, whichever you choose, because the nice thing about it is that you can also push it to a generic container registry. You're not tied to Azure Container Registry. And typically we wouldn't show the subscription here, but we're gonna tear that down after this for the demo. So
anyone who's trying to use that subscription now is gonna be dead in 5 seconds.
Yeah, exactly. But yeah, you usually wouldn't share secure information like this, but for this demo, we'll show you. And so we're pushing it to this test container registry. And so once it's built and pushed to the container registry, then we're able to actually use it. And so now we're copying a bunch of our files from our build artifacts down so that we can use it in our CD process. So those files are our tests and our deployment files, and so that will be used in our release process that I'll show shortly.
Okay, perfect. And then do we want to go ahead and showcase what we're going through on that first demo? So I'm going to go ahead and switch to this view, and you can see we're going through 2 demos, one with Team Cat, she's already started, and Team Haba. And you can see that Cat is going through showcasing how we're pulling from GitHub. We trigger our CICD, we have the UI pipeline, we do our build, test, deploy, and then we test our IoT Edge device, and then check our different Docker image.
Yep. And I'm glad you pointed out that we're using a UI pipeline. So there's 2 options that you can configure your pipeline with. And so this is the visual designer. And we decided to go this route because our team's a little bit newer to Azure DevOps, and it's a bit of an easier interface to work with. But Haddad will demonstrate later that there's also another option to configure your pipeline. And so if we jump over to our release, we're doing a CD process for our single module because our team really wants to make sure that our module has been tested and verified before we integrate it into the full solution, which Haddad will show later. So if I go into the release pipeline, you'll see I have this test stage here, and it's using the artifacts from our CI process that we just ran. And so this is generating our deployment manifest that we dropped as an artifact from our builds. And then also, once that's successful, it will deploy it to an IoT Edge device. And so we've identified which device it's going to based off of the device tags. And so this is a pipeline variable, which if you look up here is actually the humidity test device.
Okay, wonderful.
And then we are running some smoke tests against it, which is a script that is just checking if the module has been deployed and if it's running on the device. And then once that's all successful, we're going to say, we know that this is a known good version of our image, so we want to promote it to another container registry where we know these are good container images that we want to use on our actual solution. And so Haddad will demonstrate the rest of that process later. But before I get into that, I wanted to show what an actual run looks like.
And while you're showcasing that, when you are in the section of generating that manifest, it doesn't actually deploy on the edge device yet. That's just making the manifest itself, and
exactly.
then that next step is when you actually want to deploy the manifest and test it out first.
Yes, exactly. We want to generate the manifest because sometimes we have pipeline variables or other variables in there that we want to replace based off of configurable items. So we're generating that JSON file first, and then we're going to deploy it to the device. So I've opened up a successful release pipeline that we ran this morning, actually. And you can go into the logs and step into each step and get an overview of everything that's going on. So for example, the deployment part of it, it says that it's starting the deployment, and then it's checking if the deployment file is there, if it's valid JSON, and then it's pushing it down to the device that we've identified.
Okay, perfect. And then I see that there's a redeploy.
Yes.
Yeah, so any scenarios there where it's already been successful? Is there any what is the use case of doing that redeploy?
Yeah, so in the case that we say that we want to redeploy a deployment that didn't get down successfully, or the device went offline during the deployment, it'll trigger it again. So there's some checks there to like make sure that your deployment actually gets down to your device.
Yeah.
And so now if we actually step into our device, I'm going to SSH into this device to show that the modules are actually running. So I'm going to SSH into TeamCat at this IP address, which we're also tearing down, so don't try to SSH into it after this. And so now I'm in my device, which is a Linux device, and going to list all the modules that are running on the device. So you can see here we have that humidity filter module running. It's been up for about an hour because that's when we last ran the deployment, and it is tagged based off of the credentials that we gave it.
And it's nicely running successful, and if it wasn't, it would actually show something.
Yeah. If it was not successful under the status, it would say failed or something like that. And then you can also see the other modules that are running on the device also. And this status is also reported in the Azure portal also. So you get kind of two views into it in the case that you're not able to remote into your device all the time.
Yeah, and it's nice that we have those two options because not everyone wants to just go through the portal. But we're actually, when Hava comes out, we're going to go through how you can actually see it through the portal as well.
Yeah. So she'll be coming on next to show the CI/CD process for her team and also the release for our entire solution.
Great. And then I know you've been working a lot with CICD with different partners and customers. What are you seeing a lot, like different types of industries? What type of scenarios you're seeing the most when it comes to using this at this moment, this particular solution?
Yeah, we've seen it used a lot in the manufacturing industry, oil and gas, transportation, anywhere where they really want to solidify their CI/CD process so they can ship out their modules quickly and make sure that they're really tested and before that they land wherever they will, because a lot of these devices sometimes will land in a remote location. So they want to make sure that these modules are tested before they go out, because it's difficult to get those devices back all the time and then redeploy them.
Yeah, sometimes they're in the middle of an oil rig.
Yes, exactly.
So
where
we've had plenty of those.
Yeah. A lot more than we'd expect, where you just like don't have access, or you have to fly out or boat out to a location, and that's, if a deployment goes wrong, you don't really have the option of just like going whenever you want.
Yeah, exactly. Well, thank you so much, Kat, for joining and showing that first technical demo. It was nice to kind of see an end-to-end there, and also how we'll generate that deployment manifest and how we can actually deploy it onto the IoT Edge device.
Yeah, exactly.
And the right one too, because I can imagine we probably have plenty of manifests that
Yep.
we use in the different modules. Well, thank you so much, Kat.
Yeah, thanks for having me.
Yes, anytime.
I'll probably see you again on this show, maybe.
Yeah. Hopefully, yeah.
I'll
definitely.
be back. Recurring special guest.
Yes. Definitely. Okay, well, thank you so much. And
Yeah,
I think we're going to
thanks.
bring Hava in, and then, don't worry, we'll get lunch.
Yeah.
Okay, perfect. So I'm going to go ahead and move to this slide just to show you what we're going to be doing for the second one as Hadva comes in. So we went through Team Cat. This time we're going to actually be going through Team Hava. She's actually going to show what happens when you do a code change. She'll also mention what are some secure ways or some security practices you can think of when you're using CICD, and then also using YAML file too for your so YAML pipeline, and then showcasing in the Azure portal where you can see those logs and make sure everything is good to go. So hi, Hava.
Hi, Pamela.
It's great to see you.
You too.
Yes. So I want you to have an opportunity to introduce yourself. I've worked with you with partners and customers in the past. You're amazing. So I feel really spoiled. Granted, all my past speakers and deep dives, don't worry, you're all my favorites too. But I'm definitely happy that you're here. So did you want to give some background on what you do?
Yeah, so my name is Haddad. I am a software engineer in the commercial software engineering org. We are working with multiple Microsoft partners to enable them shape the DevOps story for IoT Edge and see where the pain points could be and how could we step in and help. And over the patterns that we have seen, we've came up with the most common scenarios that we have, and this is actually the main goals behind the deep dive talking today. We will want to show you those patterns and share it with you as well.
Yeah, and everything you're seeing, I make sure with deep dives, it's not just things that we just released and a partner, customer, or developer haven't gone through it. These are actually tested solutions and best practices. So I think that's really important because sometimes we'll, produce docs and guides, but we want to really make sure that that's been tested and we've got feedback, and then we're constantly adding to it. So if you do have feedback at the end, I'll tell you how you can say, hey, this part might be a little painful, or oh, I really like this part. Have you thought of adding this feature? Yeah. So I'll give some links of where you can continue to share that feedback. So I'm gonna go ahead and let you share your screen.
Yeah, so today I will be working as Team B, and as Kat walked us through earlier, Team B is working on the temperature filtering module. It's an IoT Edge module that's very simple. The sample is actually available in GitHub, and we are collaborating on that. The difference is in a team, we are using Visual Studio Code to do our code changes and then provide the workflow we are working on. So what I would like to go with everyone today in the show is actually show the workflow in live. So we will be going over a code change and see how this code change flow directly through the CI and CD till it reaches to production. So let's get started here. What I've done earlier is I cloned the GitHub repo for the temperature filtering module.
And this is actually live. If you go on GitHub right now, you actually can test this. We just made this sample for you.
Yes, it is actually there. So let me start with creating a feature branch that I will have my code changes and then go through that. So let's say update threshold. Okay. Now I have my branch updated, and what I'm really targeting in is code change is something very basic, very simple. So let's just go maybe change the threshold for the temperature constant in the code because we're not targeting something big in here. So let's go. This is a program.ts. This is where the code is in the module, and this is the temperature threshold. So let me push this value to be 25, save it, and before I actually push my changes, let me do a build.
Okay,
Because
yeah,
we want
yeah.
to make sure that whenever we change our
It's
code,
not broken.
yes,
It's always good advice.
Yes. So the way to do it here is just go to the deployment, the debug, and right click and do build IoT Edge solution. As we can see, it's building the Docker image for the Edge module, and it has successfully built the image. So we didn't do anything that broke the code in here.
That's good.
Yes.
We can sleep sound tonight.
Yep, I can have a good night's sleep. So let's just commit this change to the branch and push it to the GitHub repo where the sample is. Let me add a bit of a comment in here. And commit. And I like to use VS Code because it has this cool integration with all the Git. And if you can see here my screen, I'm just gonna do that, and that will publish a new branch for me with that name to GitHub, to where my repo is.
Perfect. And as I mentioned before, with VS Code, you also have that IoT Edge extension that just makes development for IoT Edge really easy. And
Yes. Yeah, so let's go to the GitHub repo. This is the actual repo where we had initially cloned and we are working off. And if I go, I could see that this, oh, is it still pushing? Yep, so this is a branch. Oh, it's there. This is a branch where I had my code changes, and what I'm gonna do now is I'm just gonna create a pull request to have my changes merged into master. Let's go quickly create the pull request, and usually you will have people reviewing your code changes, but for demo purposes,
we're live, so
Yeah, we're just
we're
gonna-
speeding it up.
yeah, we trust the change we made. We're just gonna merge it off. So now I had the code change merged into master. If we actually came here to the code and check the branch, you will see that I have merged my pull request into the master.
Yep.
Let's go to Azure DevOps and see what should be going on there.
Okay.
As Kat has talked a little bit earlier in the day, today every team has generated their pipelines, their CI and CD pipelines that actually triggers when any change gets merged into master. So with the code change we have just pushed now, we should see a new build gets triggered. And yes, that is the case. You can see that here, this is a new build that got triggered because of my merged pull request update of the branch of update threshold. So
Yeah.
it is up and running. So let's take a deeper look on that pipeline while it runs. One of the main difference in Team B is that we actually prefer to use the YAML pipelines instead of the designer. YAML pipelines is another format of generating your pipelines as files. It's pretty much, you can do the same, almost all the same functionality you could do through the designer, through the YAML pipelines. It's just in a different format because you'll have your file, your steps in the pipeline stored in a YAML file that gets checked in as a part of your code. The really cool feature about that is it gives you the control over the history of the pipeline and the versions of when this was changed and why and by who, and all the version control and tracking of the history of it.
Is there any you mentioned you're talking about the benefits, but what are the main differences if you were going to go the other way with the UI versus the YAML file?
There isn't really big difference. Functionalities are supported in exactly the same way in both versions. It's more of a team preference.
Okay.
And it's a choice that every team choose to do. Some might go with the UI because it's easier to read. You can just, as Kat showed us, you can go in through every step, you can check it, change stuff. But in the YAML pipeline that I'm gonna share with you all now, it's just it needs a different set of tweaks to run. But eventually you could have everything exactly as a UI implemented in YAML. So as this pipeline triggered, let's go and actually check what is this pipeline doing. So that's it. Say we click edit, we will see that this is a YAML pipeline and it's sourced on a YAML that's hosted on GitHub.
But we can have it sourced anywhere, right?
Yeah, it's usually a part of your code base, your repo. So whenever your code is hosted, this file will be in there. And that's how you keep track of it, because later on, maybe when you do a code change that maybe implement tests or do further steps, you can go back and in the same code change actually update your pipeline to run those tests. So that's how they are associated. So let's quickly go over this YAML pipeline here and see what it's doing. First thing we would notice that it gets triggered on master, and it's running on an image of Ubuntu 16.04. Then we can go ahead and define the steps. The steps are pretty much the same as Kat mentioned before. We are doing a .NET test first to run. If we have any unit tests available, we are running those. Then we are doing build Azure IoT, build the image module, and then after that we are pushing the generated modules that we have built to Azure Container Registry.
Okay, perfect.
What you could notice is how can I set the variables or the values that we used to set from the UI task in a YAML pipeline. Actually, that's very easy to do. You could actually have those here as just variables.
Okay.
And whenever you link your pipeline to a file, when you generated, no, where was that? Yeah, I think we need to go back. So here, when you link your pipeline to a file, you could actually come here and through the variables, identify all the variables and give them values in here.
That makes it a lot easier because I can imagine it's always easier to work with variables in this situation instead of just hard code. Exactly what you,
So that's how you could control your values, and you're not actually storing the values in the file. You can have a way to do it. You could still store some values in the file if you know they are fixed, like, I don't know, the name of the image. It's a personal preference or a team decision that needs to be made.
Okay.
So as we are running, let's actually check the pipeline. As we can see, it's going to execute the same steps that we talked over. It has run the tests here in this .NET test task, and actually we can see the results of the execution of the tests in here in this tab.
Okay.
So you can see like how many tests have been executed and what's the result of them and so far. And then it built the module image. And I want to go a little bit deeper in here because I want to check what was the tag that the image used to have.
Okay.
So we can see that it has generated this image, and this is the module name, and it successfully tagged it with the 0.0.56. This number actually comes from the build number.
Oh, okay.
So now we are tying an image to a build. So further ahead, when we get this image deployed, and if we maybe figured out a bug or issue, we can just, using the tag, link it to a specific set of code change that happened. And that's actually the power of using the CICD in Azure IoT module, because now you can scope what could have led to this issue, or when it was introduced, or what happened in there.
Who to track down.
Yes. So we know that this is a tag, it's 56. We are going to remember that because it's going to go over as the pipeline executes, and we can see that it pushed the image successfully to our Azure Container Registry, and it did publish some artifacts that we will be needed later in the deployment pipeline.
Perfect.
By now, we have accomplished, if we look back in here, so we have actually, here. So this is my team. We had a code change. We pushed it through a GitHub. We triggered the CI through a YAML pipeline. So we are pretty much in here.
Okay, perfect.
Because the CI we have successfully run has actually triggered a deployment pipeline
Mhm.
in the releases. So let's go to the releases tab and check this temperature filter module release.
Okay.
And again, we can see that a new release has been running for us, and you can actually link it to the build. So if you click in here in this little link, we can tie it back to the CI and the code change that we have made.
Okay, wonderful.
So let's see the logs of this release. Let's see what's going on in there. As the release is running, we can actually check the logs and see first step in the pipeline. Again, it's going to be very similar to what Team A is doing and Kat has shown before.
Yeah.
We are generating the deployment manifest that will be used in the IoT Edge deployment. If we need to inject some variables, like for example, the image URL to be tagging the image that we have just generated in the CI and using, that's where we do it here in the generate deployment manifest part. And now we have moved to the next step, which is deploying to IoT Edge devices. This is where the actual deployment to your device is happening.
So that'll deploy the manifest and the actual module themselves.
Yes, so that's where later on we can go to IoT Hub and check the IoT deployments on the hub and see that using the ID, the deployment ID, that there was a deployment. These were the targeted devices, these were the modules deployed, and these were the image URL that used in the module as well.
Okay.
So that's how we actually tie the entire story or the workflow for a single module, from starting off at code change on a developer machine to eventually have this changed bits released on a device.
Yes.
What we are showing right now is a pattern where the repo has a single module, which means it's a pattern. An organization has multiple teams. Every team is working in their own module. Modules are pretty much independent. Maybe there's no dependencies for the features when they are developed. So every module is being coded, developed, and tested in isolation.
Yes.
So that's the pattern we have been showing so far. And later on, we will show another pattern with the factory pattern, where maybe another solution is I have module A and I have module B, and my both modules needs to communicate and be on the same device, deployed on the same time. So how we are gonna handle this different pattern, that's we will go through that later on. So as you can see here, deploying to IoT Edge device step has successfully completed. We have a deployment ID here that we can track, the temperature test deployment, and right now it's running a set of smoke tests. The tests we are running here is pretty much ensuring that the modules that we have deployed were successfully deployed. It's testing them through the module twin and just making sure that devices are still connected post the deployment. Everything's up and running, nothing has crashed. And this is where, if you have tests that needs to run on a device, probably this is where you would do it post the deployment task. And if you have unit tests, probably you would do it in the CI. So again, it depends on what testing you have in your module and what is the scope of all the tests.
And while that's pulling up now, I know we were talking earlier about Key Vault.
Yes.
And while that's running, did you want to give a little bit about feature that's now supported?
Yes, so as we talked a bit earlier about how can I store my values or variables that I need to pass to either the tasks or the YAML pipeline when I execute my pipelines. And we kind of showed a little bit that this is the variable group where you could actually come and add all your values you need. But there is a good question of, or a good concern of security. What if I have credentials or secrets that I would like to store? Where should I keep those? Should I keep those in Azure DevOps, or where should I put those secrets? So the answer is yes, you could keep them in Azure DevOps. You could have them here in this way stored and just mark them as secret, and you can see that they get like little stars so no one can see the values
Yep.
or copy them. But the other approach is, can I store those values in Azure Key Vault? And Azure Key Vault is a service that's just like a vault, allows you to store secrets, certificates, or any credential sensitive information and be able to use them when needed on the fly.
Yeah.
So you could absolutely do that in here. You can have your variables actually linked to a key vault. And the cool thing about that is when you execute your pipeline will go and fetch the value. Just use it within this scope of the pipeline, and when the pipeline ends, the value has never been stored, logged, or been anywhere, not on the agent or in Azure DevOps history as well.
Okay.
So that gives more of secure way to store your values and retrieve those credentials, especially when we have scenarios where there are some policies enforced.
Yeah, that's what I was thinking, where
Yeah.
maybe every 30 days they have to change their password or
Yes.
values. Yeah.
Yeah,
Yeah.
sometimes there are policies around credentials, like their credentials needs to be rotated every month, or you want to limit credentials access from everyone. So if you have production secrets, probably you don't want to have like people in the pipeline for the staging
Exactly.
be able to see it or use it.
Yeah.
So the integration between Azure Key Vault and Azure DevOps gives this great functionality available in here.
Okay, perfect.
Let's go and check the pipeline.
So how are we doing on the pipeline?
It's still running. We see that the smoke tests have passed.
That's great.
Yes, so the deployment didn't break anything. Device is still up and running, and it has pulled the deployment, and we could verify that from the module twin. So let's do a little bit of how we tie that to the IoT portal itself.
Yeah, be able to see the logs and even see our edge devices.
Yes.
Yeah.
So let's check here for the deploy IoT Edge task. This is the deployment ID that we generated, temperature test deployment. Let's go to the IoT hub that we are using. Scroll down a little bit to IoT Edge and check the deployments. So this is the temperature test deployment that we have generated in here. Oh, where is it? Yeah, I get lost. Temperature test deployment. Yes.
There it is.
Yes. Just double checking. This is the deployment that we have generated. You can see from the timing. This is the one we have, and you can actually see that it targeted the device with a certain tag in here. And the device name is a temperature filter test. We will go back to check on the device itself, see what the modules are there, and make sure that we are running the same image that has the code change.
Okay, perfect.
But if we go over here in this tab, in the deployment tab, we can also see the deployment manifest that we generated as a part of the deployment. It's available here in the deployment on the IoT hub itself.
Okay, nice.
And we can see here that for the image of the temperature module, it's actually pulling the image that was generated in the CI and was pushed to ACR, Azure Container Registry, and now it's being injected.
So it's already on the device. This is that particular manifest that we just deployed.
Yes.
And it was successfully deployed on it,
Yes.
on the IoT Edge device. Yeah.
So it's there in the deployment, and if we went back, this is a device ID. We could double check.
And is this just the temperature module? Do we have both the temperature and humidity?
We will have that in the factory pipeline when we talk about it a little bit later, but for now we are just doing the workflow for a single module, which is temperature filtering module. So this is device temperature filter, and this is the module that we have just pushed. And I have an Azure map, so I can see the values, but probably I could copy them in a notepad. And yes, if you notice, this is the exact image that we generated in CI.
It was successful.
Yes. So now we have a full end-to-end scenario from a code change to a deployment on a device running in the edge.
That's perfect. And I saw earlier there was different stages. I don't know if you wanted to talk about staging at all, but I noticed that there was different stages and that you can set manually when you actually deploy, which is nice because you can actually do a manual before you even deploy the manifest to the edge device. And what that means is that you can actually say, hey, before it goes to this step, these people have to look and give the thumbs up that this is good to go. And that's really nice because there's going to be tons of teams working on this. So to be able to have those kind of manual stops is also really helpful.
So this is another pattern that some people might want to follow is, well, I have a different set of environments in my release cycle. Let's say initially I deploy to testing environment, and then I let my tests run. Probably have other teams of manual testing come and do their work, check everything is going fine, and then eventually they have to approve that, okay, that's working, this can go ahead and be actually deployed to production. So we could totally implement that in a deployment pipeline, and this is actually the one we will be showing for the next scenario, which is a factory module.
Okay, perfect.
So what we have done is just the entire scenario for a single module. Now let's move back to the case of, okay, but I have a set of modules that needs to work together to have a complete solution. Maybe a module A is doing some sort of taking pictures, and module B is running an ML on those images to do some sort of predicted maintenance. So we have seen multiple patterns with that, and that's totally fine. Modules can be independent and can have dependencies in them, but how we could handle the release pipeline if we have dependencies?
That'd be perfect to deep dive in because that's definitely what I see as a common pattern. My last partner I was working with, many teams building different modules, and especially when you start bringing ML and bringing in your ML experts, AI experts, and they're building their own modules. They have totally different tooling that they're using and preferences, and so it's interesting when you have all of these different teams. So I think all of these are realistic scenarios, and I think this one is the one we get the most question on.
So how do you implement that? For this specific case, we are gonna host a third repo. So we remember module A had its own repo, module B had its own repo. The integration solution will have a third repo. The repo will not have code bases per se. It will mostly host the deployment manifests for this. And you can think about it as a combination of, if I want A to work with B, then this is the versions of A that's compatible with this version of B, and maybe those are the routes that I need to define between the modules. If I need to set some variables for the module twins. So that's where you have those specific details about how the two modules work together on that same device. Let's go a little bit over that. So we have a sample repo up as well in GitHub. And in this repo, we are going to be showing the deployment manifest for the solution factory. And if we go over that, we will see that we have some variables to pull the images from Azure Container Registries. And then let's go to the most interesting part of how we configure the modules working together.
Okay.
So here we see that we have the humidity filter module, and we specify that this is a way to pull the image for the specific module when you deploy.
Okay.
And this is a temperature filter module, and this is the image that we will be using. You can notice that the Azure Container Registry address is a variable.
Yeah, that makes sense.
Yeah, because we don't know. We won't let them have the control of changing that on the runtime. Maybe I'm deploying from a staging Azure Container Registry or a test container registry. Again, they could have it fixed, they could have it variables. It's a choice. But what we have here fixed is the version of the image.
Ah, yes.
Yes, and we could still have those as variables, but it's more of, I want to keep track of history of what image, what version of image A was compatible with what image of version or module B.
Okay. Yeah.
So when you do that, and then later on you want to change in the deployment manifest, let's say module B has, or the temperature module has pushed some updates that will work perfectly fine with the first module. We come here and we do a code change, a PR, to bump this version, and that gives us track of the history of, oh, when did we do that change, when A become compatible with B, and what changes did we do in the routing, and all this information. So that's how the two modules are tied together, and we can see that if we need routes, it could be specified in the routes section, and we have everything ready. So how can we do a release pipeline for that? Let's come over here, and we are not gonna be running a release in live just because of the timing it takes, but we will. Yes.
Exactly. Sometimes it takes a little too long with the live demos, but yeah.
Yes. So we're just gonna go over the last successful execution of that pipeline and talk about what's there.
Okay.
The main difference you would notice here is we don't have a CI. We have we are depending on the images being ready previously.
Yeah.
Because supposedly when every module was deployed, when was developed and coded, it was developed, it was tested, it was pushed to a staging or a ready-to-use Azure Container Registry where I can just pull this one and deploy and test my factory solution. So we have no build pipeline for this specific scenario.
Okay.
It's starting from a release pipeline. And the artifacts we are linking to the deployment manifest that we have just gone through. In here, you could actually link it to a change. So if you look here, you see that this pipeline would get triggered every time the deployment manifest have a change in it. So let's come back here and see what's actually happening in the stages or the deployment. First thing we would notice is this is multi-stage pipeline. So there's two environments that we are deploying to, and there is set of steps that needs to happen between those different two environments. Let's take a closer look here. So for the first environment, which is the staging one, you will notice that, oh, it's just generating the deployment manifest, which is tied to the factory manifest, replacing the variables if any is needed, and then do the actual deployment from the generated manifest. And of course, if you have any set of tests, you can run it post that.
Yeah.
But then there is a second task, which is the manual intervention.
Yes, that's what I jumped way too early on that because I was pretty excited about it, but go ahead.
So the reason is why some people could choose to have a manual intervention step between environments is, okay, I am okay with having everything pushed to staging, but I want to have the upper hand when it comes to production deployment. Even though if I have an automatic deployment, but I have a set of steps that needs to be executed manually, or Maybe I have a process to follow, or a protocol for inspection or whatever. They could have their own reasons, and it's all supported in here. You just add a manual intervention step, and actually in this you could specify certain emails that gets notified when a release candidate is done through the staging and is waiting to be deployed to production. So people can come and like approve or reject, and it can go back. It can go to the production, or it can just die in staging if it got rejected.
Yeah.
Going back in here, after it gets approved, it just moves to the next stage, which is production. And production should be very simple step. Just have the manifest deployed to the production devices. Maybe if you have like a couple of tests that you like to run, you could run those tests as well, and your devices are up and running. So probably you can just go ahead and use them, or check SSH maybe to double check that the device had the updated modules. It's every team's call on what to do post production deployment at this point. Also for this, we can go back to the IoT hub, and we can see that for the factory pipelines that we were just going through, we have 2 deployments here, one for each stage. So we have one for the test stage, which is the staging, and we have a second one for production. And the same way we went through, you could check the deployment manifest, you could check the devices targeted, and you can verify that it was actually updated and it's running the actual images now.
Okay, perfect. It's nice to see that everything went successful.
Yes.
And we showed an example where there could be multiple teams working on different modules and how to deploy that, and some best practices there. And also how you could do it securely too, which is really important, of course. So thank you so much for coming to show all of the pipeline and being brave enough to show it on live.
Yes.
The smoke test, we were like, come on.
Yes, sometimes like pipelines feel in your life and just take a bit longer.
So definitely. But thank you so much for coming.
Thank you, Pamela.
And I'll talk to you soon. Thank you.
Yeah, sure. Thank you.
In like
everyone.
5 minutes.
Yeah,
Okay, thank you. So we're actually gonna have Shen come back. He is going to showcase a Jenkins demo. Thank you everyone who's really patient on online waiting. I know we're over. This is on demand afterwards, right after. So if you have to jump to a meeting or anything like that, go ahead. But thank you for staying, and we have people, they're ready for this demo.
Yeah, I just got a new job outside.
Oh, did you? You just got a new job?
Right.
Okay.
So I need to reintroduce myself. My name is Xing,
Okay.
and now I become a Java developer.
You're a Java developer now.
Right,
No
yeah.
longer PM. You're now a Java developer. You could be both, but yes, yeah.
The reason I come here is because I am not really a Microsoft fan, because I'm a Java developer.
Okay.
I like to, really learn doing Java stuff in IoT world.
Okay.
So I can
Yeah.
share some findings with you. Recently I heard that Microsoft started to invest Java world.
We are. We're doing a lot of support and new features coming out to support Java. Yeah.
Okay.
Yeah.
So I start to, thinking perhaps I can use Microsoft technology with Java stuff in my IoT business.
Okay.
So here I'm actually showing my VS Code window. I recently learned that we have a great Java support for Visual Code. So I installed the Java extension pack and also the IoT tools for my IoT Edge development.
Okay.
I found that I can create a very simple Java Maven project for my IoT Edge module.
Okay.
So the reason I'm doing that because usually I use Eclipse or IntelliJ for my Java development. But if you're thinking about IoT Edge, it's all about container running on your small device.
Yeah.
The container, the logic, the code, just like several hundred lines of code, that's super lightweight.
Yeah.
right? Can I just use an editor to accomplish my daily job?
Yeah.
By using all these combinations from all the extensions from in VS Code Marketplace, I found it super useful. I can see the Maven projects, Maven plugins here. I can list all the Java dependencies here. I also get Azure IoT Hub tree views. I can see all the IoT Edge device and modules running in this window.
Yeah, it's nice to have that extra support there. From
Right,
Edge.
yeah.
Yeah.
And now I kind of I can debug and run all the modules in Visual Studio Code now. What I need to what I want to do is like start the IoT Edge module project in my VS Code IoT Edge simulator.
Okay.
So I start running all the modules in a simulated environment. You can see I'm building all the containers locally. I'm pulling some IoT Edge simulator from the Azure Container Registry.
Okay.
And the filter module start to receive the data from my simulated sensor and printed out some of the simulated filtered temperature sensor data here. And I can start to debug my Java code in VS Code, debug window.
Okay.
You can see the breakpoint has been
Yep.
hit. So now I kind of completed a single module development job. Now I need to do some thinking about, I need to start a team doing this module and start perform some CICD, start making sure I have great quality of this module. So in my company, there is a quite interesting scenario. It's like we don't want to do everything on the cloud, especially for our tools. That's our resources. That's our stuff. We want to make sure they are running on-prem.
That makes sense. Yeah.
Yeah. So Java, in Java world, actually, we are using Jenkins. Jenkins is quite famous in Java world. And when searching Jenkins, Jenkins documentation, we found Microsoft actually provide Azure IoT Edge plugin to us. So I look into the plugin page. It introduced me how to thinking about build the CICD pipeline with Jenkins extension. It provides a great UI if you want to learn everything about your Jenkins pipeline. We have build task to push to build a Docker image. We can push to Azure Container Registry. We can generate the deploy manifest and deploy to your IoT Edge device at scale.
So the same things that you were able to do that we just showcased in Azure DevOps. If you're already using Jenkins, you can still work with Azure Container Registry. You could still create that manifest and do deployment.
Of course, I just learned a lot from Haddad and Cat. I think the similar methodology can be also performed in Jenkins world. The DevOps kind of philosophy is platform agnostic. I can also perform their practice in Jenkins system. So I installed this Jenkins extension in my on-prem Jenkins. You can see I'm using a local, web server which already installed my Jenkins system.
Okay.
Here I push my my Java project to a private repository, and I start to integrate those repository in my Jenkins build task. So you can configure this task here. Here, if you scroll down, you can see I'm actually integrate my private GitHub repository. And you scroll down a little bit, you can see in the build pipeline, we can build the image, specify the deploy manifest, connect to your Azure Container Registry, push the Docker image to a container registry. You have to set up the service principal here, which allows you to list all the your Azure resources here. I think Microsoft already have a great integration on this part. By some simple configuration, you can list all the resource by the drop down and specify your container registry. you can see I can actually list all my resource group name and find my container registry here. If you are using Docker Hub, or you might host your on-prem Docker registry, you can select the common Docker registry, put the credentials here. You can also push your container registry to that place. And then once I finish the build and test and push my kind of production-ready image to my registry, I need to think about how to deploy to IoT Edge.
Yeah.
Again, like we just had our demo, and we have the perhaps the solution ops thinking about different configurations for different types of environment, deploy to different groups of device. We have the deployment template manifest for that. You can generate the target, the final deployment manifest, and you can deploy to IoT Edge. Again, in the deployment task, we have service principal integrated here. You can browse all your Azure resource groups. You can list your IoT Hub's name in the drop-down list. Easily just select from the IoT Hub instance here.
Okay.
You can specify the deployment ID, the priority, the similar concept in just in Azure Pipelines. You can deploy to your target group of IoT Edge device with your specified deployment target or tags you have specified for those devices. That's a quite straightforward demo, and I think Microsoft have a great support on Java, and I saw you have a.
I did. I actually I heard that you were gonna act like a Java developer, so I made you a sticker for your.
Cool.
So it's a little Microsoft Hearts Java. So this you can show your Java pride.
Of course.
And put it on your laptop, on your Mac. Put it on your Mac.
Of course, I'm using Mac.
Yes. But thank you for showcasing Jenkins and the support that we have there. It's nice that we do offer support across different platforms, across different tooling as well. That way, teams don't have to completely change what they're working with, because we already know building IoT solutions is, not you want to go as fast as possible sometimes just to get into production. And so I'm thanking everyone who joined the deep dive. I want to make sure that everyone knows the resources. So we created this deck for all of you guys, or everyone viewing, and then anyone who joins on demand. We have a link of resources. We have our IoT tech community. If you haven't been there before, definitely go. I'll do a plug for that in 2 seconds. But feedback, if you really want to give feedback, we really want to hear it, because all of these changes and new features that you've seen come online is because it's feedback directly from the customer partners, from developers like yourself. So we're constantly monitoring the feedback and making those changes. So if you see something, definitely tell us if there's a new feature you want along the way. We also have other video about IoT Edge DevOps. Paul DiCarlo, one of our cloud advocates, he did IoT show video a while back. He's actually on the chat room right now. So hi Paul. thanks for helping with questions on there. And then if you just really want to read about continuous integration and continuous deployment with IoT Edge, we actually have full docs supporting it, and we have a GitHub repo for you. And then for future deep dives, if you have an idea of a topic you want us to deep dive in, let me know. You can at me at Twitter at AltaOhms, or you could use a hashtag deep dive. So definitely I'm trying to be better at Twitter. So so if you don't see a response in the first 5 seconds, don't worry, I'll get to you. But thank you so much for everyone for joining, and we'll hope to see you in the next deep dive. Thank you.
Thank you.